Hello, AP Statistics. Today we're going to talk about center and describing distributions with numbers. So, center you've definitely talked about before. We're going to go into details about the mean and the median. So, the mean is denoted by X bar. That's crucial that you understand the notations for how these are denoted. So, X bar versus we're going to talk about the median, which is a M. So mean is the average value. You add up all the values and divide by the number of observations. The mean is sensitive to a few extreme observations. This is imperative that you understand this. It comes up in all sorts of different ways all throughout the year. So the mean is sensitive to extreme observations. It's also known as non-resistant. It's the non-resistant measure of center. Because if you throw in an extreme data observation, then it can drastically change the mean. So it's non-resistant. Okay, here's the formula. X bar, sum the values over n. You can also use summation notation to describe that. Example 16, we're going to skip for right now because I want to show you how to do that in the list in the calculator to get you used to that. So we're going to skip that. Jump down to the median. The median is the midpoint of the distribution. Okay, it's the number such that half the observations are smaller and half are larger. Okay, it's the number just right in the middle when you order them in order. Okay, so to find the median by hand, your calculator also does it for you, but to find it by hand, you order the observations in order from smallest to largest. Then to find the location for where the median is, rather than crossing off one at the bottom and one at the top and working your way down until you get to the middle, it's much easier to know the number of observations you need to find the median. So if the total number of observations is odd, so say you have 7 values in your data set, then the median occurs at the location n plus 1 over 2. This is the location. Okay, so here's a quick example. If we had 7 data values, well, let's just change it to 5. Actually, it's just easier. 1, 2, 3, 4, 5. 5 observations. The location for where the median is, if you do 5 plus 1 is 6 divided by 2, it's going to be at the third location. So here's the first location, second location. Here's your median. It's at the third location. Okay. If the number of observations is even, so a different example, if I had 2, 4, 6, 8, 10, 12. Say that's my data set. So I have 2, 4, 6 observations. Then you take the average of the 2 observations in the center of the list. Okay, so another way you can do that, so if you look at, I have 6 observations plus 1 following this formula is 7 divided by 2, it's 3.5. So it's going to be in between the third and fourth value. So that's where your median is going to be. It's going to be the average of those. So in this case, it'd be 7. Okay, so that just tells you, again, it's the location. Okay, so dealing with mean a little bit, we're going to use this little example. So here are some prices for 4 recent home sales in El Dorado Hills. Find the median and median home sale price. So I want you to grab your calculator if you don't already have that. So you can put this on pause for a second. Grab your calculator and you can enter these in the list so that you can do one variable stats and find the mean and the median. So go ahead and do that. Okay, you should find that your mean, the X bar, is 617,958. The median, capital M, it gives it to you if you scroll down, 606,950. Okay, so that's the median. What do you notice about the mean and the median? They're relatively close. They're not that far apart. We have a pretty symmetric data set where there's not like one large value or one small value. So they're relatively close. especially for home sale prices. 617,606 or almost 607,000. That's relatively close. Okay. Another house just sold for 1.5 million. Add this value to the data set and find the new mean and median for all 5 home sale prices. So add 1.5 million into your list, so it's the 5th data observation, and then do one variable statistics and find your new X bar in median. Okay, so X bar here changes to 794, 366.4, and the median is 624,900. Okay, the median just bumps up to the next number that we had in the data set because we added